Okay, we're diving back into VSEPR theory. We're talking about four electron groups here when we're doing this. Remember, this is about figuring out electron geometry and molecular geometry of stuff. Um, yeah, remember, we're talking about valence shell electron pair repulsion. So this is how we're going to figure out uh, geometry as we do this. Remember, you have to have a good Lewis structure when we do this. Um, and we're going to be counting electron groups. So I want to refresh ourselves here about electron groups. Again, right? Electron group, lone pair, single bond, double bond, triple bond, right? Each one of those is one electron group, okay? I'm going to flip them back and forth again between this simulation that's linked in our course Blackboard page and this PowerPoint as we go, okay? So let's dive in. I gave 4 its own video because 4 is probably the most common thing that we're going to see. And now we're no longer planar. Remember, we had linear and trigonal planar before. This is now what we call tetrahedral, right? Ooh, crap, come back. When it's tetrahedral, um, you can think of it as it looks like a pyramid. It's a 4-sided pyramid. If you're one of those multi-sided dice playing people like I am, then you'll be used to the 4-sided die. It's the same kind of idea. The central atom is in the center of the tetrahedron, and then the outer atoms are on each corner of the tetrahedron, and you have this 3-dimensional shape that does that. Okay. Again, you can look at it as 4 balloons held in the center. And the nice thing about this is all the angles are 109.5. So we have another angle to remember here. 109.5 is a good tetrahedral angle for us to look at. Let's look at something tetrahedral in our simulation that I've lost. There it is. Aha, okay. We're going to pull up. Do we have it? Yes, CH4. Eventually, we're going to run out of things that are in the molecule stuff. There we go. Let me get, okay. Yeah, for methane, all these angles are 109.5. Turn those off just so we can see it. Yeah, so in every case, you can find a plane that has the central atoms and the central atom and 2 of the hydrogens, right? There's those 2. If we turn it this way, there's those 2. That's kind of characteristic of tetrahedral things as well. Okay. Right. Let me switch back to PowerPoint. Good. All right. While we're thinking about it, we need to have a way to represent 3-dimensional stuff in a 2-dimensional medium because we're going to be drawing these a lot. When we get into organic chemistry, you'll be using this convention a lot. I'm not going to ask you to draw anything this way, but I do need you to recognize what these symbols mean because you will see them in stuff. And we call these things wedges and dashes. Okay. Every time we look at this, there are 2 things that are 2 of the bonds are in the plane. So this is in the plane of the screen, and this is in the plane of the screen. Okay. There's one that's coming out at us, right, towards us. So this one we represent as a wedge. And I'll draw this as a Lewis structure in a second. And this one's going away. So we can think of this, I don't like at us. How about towards? There we go. So this one's coming towards us and the other one's going away from us. So this is a dash. Okay. So if we were going to draw a Lewis structure that indicated the geometry of this, then we would have to put carbon in the center. We would have 2 bonds to hydrogen thusly. Okay. We would give a wedge to one of them, and we would give a dash to the other one. Okay. And so the wedge and the dash tell you, okay, this thing has 4 electron groups, so we should know it's tetrahedral. One of those hydrogens is pointing at us, one of those hydrogens is pointing away from us, and 2 of them are in the plane of the screen or the whatever you want to think about, the piece of paper or the board or whatever we're drawing on. Okay. Excuse me. Yeah. And if you don't have any lone pairs on your central atom, then the geometry and the shape are the same thing, and they're both called tetrahedral. So for methane here, CH4, we're going to say this is the tetrahedral geometry and a tetrahedral shape. Okay, and all the angles are 109.5. We start having lone pairs in there, then we're going to have different shapes for the same geometry. Okay, so if we look at ammonia and we look at water, okay, ammonia NH3, remember there's a lone pair on the nitrogen. Um, this is 4 electron groups because we have 1, 2, 3 bonds and a lone pair, so that's 4. So the geometry is tetrahedral, but we call this shape trigonal pyramidal because it's a 3-sided pyramid if you don't count the lone pair, right? So shape only accounts for the atoms. When we get to water, there's 2 lone pairs on the oxygen. So our good Lewis structure for water, and I bet everyone draws it this way, and that's fine. But we want to get out of this idea, this thinking about water being linear, because water is not linear. Okay, water is bent, and it's bent because we have these 2 lone pairs. Because there's 4 electron groups, um, there, that's tetrahedral geometry, and the 2 lone pairs makes it bent. Okay, we can look at our shapes here. I bet you ammonia and water are here. There's some ammonia, right? So it's still tetrahedral. We still have 4 electron groups, 3 bonds and a lone pair, okay? But it's called trigonal pyramidal when we do that. We can take out the lone pair and just look at what the shape of this thing is, right? I can't get it seem to rotate. There we go. Very well, okay? And it is definitely not planar. There's our lone pair. There's our bond angles. These bond angles are going to be a little off, but 109.5 is fine. Okay. Water, same idea. Okay. Remember, we can say you can always get 2 in a plane and 2 that are out of the plane. So if the plane of the screen here has the 2 lone pairs in it, then we have the perpendicular plane of it has the 2 hydrogen atoms in it. So often we'll just draw water without wedges and dashes because we don't need to. And there we go. And we have bent that way. Okay. So those are the options we have: tetrahedral, trigonal pyramidal, and bent. Okay. That's it for 4 geometry. We'll come back and talk about 5 and 6 later. Okay. Let me know if you have questions and keep in touch.